This video is about the weighted average formula. Now we all know the old grade school way of finding an average, which is adding up a series of values and then dividing by the total number of those values. But here we want to find the average a different way. It's called a weighted average. And it's especially useful in statistics when we have several repeated entries. It can make the calculations faster. So instead of doing 70 plus 80 plus 80 and then adding 5 90s in a row, and then 2 100s, and then dividing by 10 here, what we can do instead is use the weighted average formula, which says you multiply each item times the number of repetitions. There is 170, 2 80s, 5 90s, and 2 100s. And rather than dividing by 10 here, we add up the sum of the weights. So the weights are sometimes they're called the frequencies, the number of times the different elements occurred. And the values are the actual scores that they got on this lab. Either way we do it, we get 88 as the final answer. Now we can also use this same approach when dealing with percentages. Question says, assume that in a certain college course, test scores make up 50% of a student's grade, and online homework makes up 20% of the grade. Let's say a particular student has 95 average on tests and a 50 average on the homework. What would be the grades so far between these two categories? So a percent is out of 100. And one of the things we could do is say that there will be 50 parts of a test average, and the grade is made up of 20 parts homework. And then we would divide by 50 plus 20. That'd be an easy way to do it. So, let's see, we'll get 50 times 95 average on tests, 20 times a 50 average on homework, divide by 70, uh, 82.14. That's the weighted average. Now let's try a physical application of this. Find the center of mass in the x dimension of this arrangement of 6 identical particles and use a weighted average. So it should be clear there isn't perfect horizontal symmetry here. For example, the center of mass would likely not be located right in the center of the two. Because we have heavier weight over here to the right, that's going to pull our center of mass to the right. But let's use the weighted average formula to figure out where the center of mass actually is. Here's how we'll do it. We'll do a sum of the weights times their positions, and then divide by the sum of the weights. It's actually the same kind of formula that we had used above, but here the masses of the objects would be the weights, and the location is their value. So we want to do, there's 1 kilogram, and it's located at a position of 0. We have 2 kilograms located at a position of 2. And we have 3 kilograms located at a position of 4. Now we just have to divide by the sum of the weights. 1 kilogram plus 2 kilogram plus 3 kilograms. Sometimes the hardest thing in the weighted average formula is to figure out what is the value and what is the weight. And so you might ask yourself, what is the type of quantity that I'm trying to find an average of? I'm trying to find an average position, right? So that's why the positions need to be in the numerator, and the masses need to be in both the numerator and the denominator. Sometimes that's the trickiest part. Okay, we're going to get 16 over 6. Which is 8/3 meters. 8/3 is approximately 2.67. Okay, so our actual center of mass in the x dimension is located right here.